Now that we've covered the basics of AFNI subject.py, we'll look at some more advanced examples. The ones I'm using here come in the AFNI_data6 dataset that you can download from the AFNI website. Within these, we have several different scripts which show different AFNI_subject.py commands. So, just to let you know, we're within the AFNI data6/FT analysis directory. Let's look at so1 ap.simple. This is just a template for an AFNI proc.py command specifying the subject ID to be FT, the datasets to be these epi datasets within an FT directory, copy the anatomical dataset to make a backup copy, and remove the first two TRs when running 3D TCAT. In addition, it specifies the STIM timing files and provides labels for those files as the visual and the auditory regressors, respectively. It also gives the basis function for those files. So for each time that one of those pops up, it convolves it with a block basis function of 20 seconds. Lastly, it feeds in some options to 3D deconvolve, specifying that there should be a contrast between the visual and the auditory regressors, or beta weights. And this will be the output label in that data set. So let's see what happens when we actually run that sample script. So all it's done is it's created essentially a template script. Okay, that's been generated in this proc.ft. So similar to what we did before with looking at AFNI_subject.py with the ask me command, it does a lot of the same things. Okay, so TCAT, 3D TOutCount, T-shift or slice timing correction, volume registration, all of that is pretty much the same. With those additional 3D deconvolve options, it's now given us a contrast, this GLT sim right here, taking the difference between the beta weights of the auditory and the visual regressors. Okay, so if you actually want to run that, you can just copy and paste this command right here that it outputs. Let's see one more example in this so2.ap.align. Very similar to the other one. It's used some variables just to cut down on some of the repetition. And within this, all we see that's really different is now we have this volreg TLC warp step. What this will do is it will both align your epi to your anatomical image and carry out a warp to a standardized space, in this case, a TallyRack space. Okay, a lot of the rest of these are very similar. You can see that there's a command for censoring any TRs which have motion greater than 0.3. And also, we can specify the amount of jobs we want if your computer has multiple CPUs to make the 3D deconvolve process go much faster. We're going to look at one more example here. Again, this is another script that's been output, but if you want to see how this was created, simply go down to the very bottom and then look at this afniproc.py command. This has all been commented out, but you can use it and modify it if you need to. So those are some more advanced examples with afniproc.py. Again, I don't recommend making one from scratch. I recommend using one of these templates that you can download from the AFNI website. It makes it much easier and you get a better idea of what's going on. These scripts need to be modified to work with your specific data set, but once you get that working, it should be relatively straightforward to make it process your fMRI data.